Good afternoon, my YouTube viewers. It is Crystal here, and what I want to do is I want to do a code review on a Kaggle community competition question, and the community competition question is 2023 Deep Learning HW2 Transformer. So I was just assuming, since they had the word transformer in their competition question, I was just assuming that they wanted us to use a transformer. So I thought that this would be a really good idea to try out BERT. So this was HW2 Transformer TF BERT for TensorFlow. And I tried out BERT, and when I tried it out, I got a 62.5% accuracy, which, it's not great, but, I had to do my best. So, and I think I scored, if you look over here in the competitions, I scored 2 out of 3. So, at least I attempted the community competition. And I think that I prefer doing community competitions because I'm not living in the United States. And since I'm not living in the United States, I can't really go collect the prize, because if you enter a competition, then you have to go to the U.S. to actually collect the prize. And I haven't got an up-to-date passport. So if it ever gets to the point to where I want to be serious about entering competitions on Kaggle, then I've got to get my passport updated because it's not up to date and I wouldn't be able to use it. So that's another thing I need to do, is if I decide to start entering competitions, to get a new passport. So what we'll do is we'll talk about the competition question. So this is your problem statement. This is the Kaggle competition for HW2 in NYCU Deep Learning course. NYC, believe it's New York City, and then U, I guess, is university. Given the headline and the content of the news, you need to train a model to correctly classify the news into 4 different categories. So 1 is sports, 2 is business, 3 is tech, 4 is media. So the first thing we're going to do is we're going to import the libraries that we're going to need for this competition question. So we're going to import NumPy as NP, which creates your NumPy arrays and does your numerical computations. We're going to import pandas as PD, which creates your data frames and series and does data processing. We're going to import OS, which goes into the operating system. We're going to import matplotlib.pyplot as PLT, which visualizes your data. And we're going to import Seaborn as SNS, which visualizes your data statistically. Then what we're going to do is we're going to go use the OS library to go into the operating system and retrieve the files. So there are 3 CSV files, being sample submission, train, and test. Now what we're going to do is we're going to use pandas to read the files. So it's going to be train equals pd.readcsv, and then the UTL, or the web address for the train.csv file. You use the same methodology for test and submission as well. We look at the train file, so you see that you've got an ID, a category, a headline, and a short description. So we check train info. You see the ID and category are integers, and headline and short description are objects. We're going to check for any null values, and short description has 17 values that are null. So what we're going to do is we're going to replace the null values just with the space. So, and then what we're going to do is we're going to check and see if there are any null values again. We don't have any null values, so you can see that it was successful. Now what we're going to do, this is what I did. What we're going to do is we're going to take the headline and then we're going to add it to the short description and call that description. So you're going to have headline and then a space and then a short description. So you're going to get all of the text in. And I did that. I just came up with that. Now you're going to check your test file. Notice the test file doesn't have a category, and the reason why is because you're going to have to make predictions on that. We check the info, so you've got one column that's an integer and two columns that are objects. We check for any blank values, and you've got 28 null values. So what you do is you replace any null values with a space. That's what you're going to do, replace any null values with a space. We check for null values again, and you don't have any null values, so you can see that we were successful. And then so test description equals test headline plus space plus test short description. So you can see that there's a description, which is what we want to use. Now we have a submission. So your submission is going to be your ID and your category, and that's what you're going to submit to Kaggle. So we're going to check submission category value counts. You can see you've got 103 threes, 101 ones, 99 twos, and 97 fours. So now what we're going to do is we're going to analyze the target. So we do SNS.displot train category, KDE, that's kernel density estimator, I believe. So you've got 1, 2, 3, 4, and it looks like they're all close to 500. Now we do a value counts on train, and yeah, each category has 500 examples. Now what you're going to do is we're going to define our X, Y, and X test. So your Y is your train pop category, your X is your train pop description, your X test is your test pop description, and then we're going to check the shapes. Now what we're going to do is we're going to use train test split with sklearn to split the data set into a training and a validation set. So that's what we've done. So we do num label equals Y train in unique. So that means there's 4 distinct categories for unique values. Now we're going into BERT and TensorFlow. So what you're going to want to do is you're going to want to import all of the TensorFlow libraries that you're going to need to run the program. You always want to print off what version of TensorFlow you're using, and the reason why is because TensorFlow goes through so many changes. At the moment we're on TensorFlow 2.12, and although we're not on 2.12 here, we're on 2.11 here, but I think on my Google Colab, I think it's 2.12. And so TensorFlow goes through so many changes that you always want to know what version of TensorFlow you're on, because a lot of the code gets deprecated when they make changes. Now what we're going to do is we're going to convert the Y train and the Y bell. We're going to one-hot encode it, but you have to do it to import it from Keras to do it. Well, the thing is in Python, the first digit is a 0, but in this particular program, the 4 categories start with 0, the 4 categories start with 1, 2, 3, 4. And so, since the first digit starts with 0, then what's going to happen, it's going to give you 5 categories. And I know this because I spent a lot of time trying to figure it out. And how I got around the problem. Now, what we could have done at the very beginning of the program, we could have encoded. We could have encoded the categories. using a label encoder, but if you encoded the categories using a label encoder, then at the end of the program, when you predicted on it, then when you got your predictions, then what you would have to do is you would have to invert or reverse that label encoding. So that's another way that you could have gone about it. But, there's lots of ways to actually go about it. That was one way, is to use sklearn's label encoder. Another way that you could have gone about it is to do a replace. But I just thought that the best way to do this, and I found it on Stack Overflow, is to make ytrain equals ytrain minus 1, yval equals yval minus 1. So that means that if the prediction was a 1, then it will convert it to 0. And if the prediction was a 4, then it would convert it to 3. And so what we do, and you have to do that way. That's the way I did it. That's why I thought it would be the simplest way to do it. I didn't want to label encode it, but I could have labeled encoded. But you need to keep in mind that if you label encode it at the end of the program, when you get your predictions, you need to reverse the encoding. So there's lots of ways that you can go about doing this, and you can also do like a replace. Now the thing is that after I decreased ytrain and yval by 1, you do ytrain equals 2 categorical ytrain and yval equals 2 categorical yval. Now the default, like the number of the number of classes, the default is none. And then so if you don't say anything, then it will automatically set it up for the default as being none. And then none is going to be the number of classes minus 1. And so that's why, and I tried my best. I tried my very best to say num classes equals 4, and then what it did, when you say num classes equals 4, then what it does is it gives you 5 classes because it counts 0 as a class. And so, I spent a lot of time trying to figure this out, which is why I am explaining this to you, because I don't want you to make the same, spend all the time that I spent. So the best way to do it is ytrain equals ytrain minus 1, yval equals yval minus 1, and then you set it up to categorical, and then what happens is, because the default is none, then it's going to set the num classes as being num classes minus 1. So if you've got 4 classes, it's going to set it up for 3 classes. And if you've got 5 classes, it's going to set it up for 4 classes. But if you set it up for num classes equals 4, it will go into error, or whenever you try to train it, because when you try to train it, it will say that there's 5 classes, which there's not 5 classes. That's just an error in the system, an anomaly of the system. So I'm just showing you how I got around it. And then what you want to do is you want to import or install your BERT. So BERT preprocess equals hub.carousel, and it gives you the website address for the BERT preprocessing. And BERT encoder equals hub.carousel, and then it gives you the website address for BERT encased. So, and then after you do that, you want to set up initialize the BERT layer. So text input equals tf.carousel input, shape equals brackets, dot, comma, dtype equals tf.string, name equals text, and preprocess text equals BERT preprocess text input, inputs equals BERT encoder preprocess text. And so, that's another preprocessing layer. And then what you want to do is, after you set up your BERT, what you want to do is you want to initialize your neural network layers. So L equals tf.keras.layers dropout 0.1 says name equals dropout. So I could make it dropout is 0.2 or even dropout 0.5 to see if I could improve my score. And I just might do that, see if I can improve the score. And then L equals tf.keras.layers dense num label. So num label is going to be 4. Activation equals softmax. Name equals output L. And then now we create our model. Model equals tf.keras.model. Inputs equals text input. Outputs equals L. And then you have your model summary. So this is a summary of your model with your bar. So you can see it's pretty good size. So now what we do is we compile the model and we use loss equals categorical cross entropy, optimizer equals atom, metrics equals accuracy. And now what we do is we train the model, and I set it up for 15 epochs because it took such a long time. But you can set it up for more epochs. You can set it up for as many epochs as you want, and you can also set it up for early stopping, which I didn't do in this occasion, but I could have set it up for early stopping. But with how many epochs did I say I was setting it up for? 15 epochs. So if I set it up for more epochs, like 20, I may have got a higher level of accuracy. And then we check the results equals model evaluate x val y val batch size equals 128. So you've got your loss is 0.84 and accuracy is 0.71. And now we make our predictions. So predictions equals np.argmax model.predict x text. Axis equals -1. Then you have to go back. Predictions equals predictions plus 1 because you have to reverse what we had done earlier on in the program. Predictions equals predictions dot flatten, and then you have your predictions. And so you've got all these pretty predictions, 1, 2, 3, 4. So now what we do is we prepare our submission, and when we prepare our submission, so submission category equals predictions, submission to CSV, bracket submission CSV index equals false, submission equals PD read CSV, submission.csv, and submission. So you can see that this is what was submitted. So that's the code review for what we have done. That's the code review for what we have done. And you can see that like when I submitted my predictions to Kaggle, I got a 62.5. But if you want to come over here, you see I'm number 2 of 3. So at least I attempted it. At least I attempted it. So you can see here's the leaderboard here. And I don't know, maybe I'll get a medal, who knows. It said advanced line is 79.5% and baseline is 74.5%, and I got 62.5%. So, I don't know, maybe I'll do a little bit more work on this and see if I can improve my score. Maybe improve the dropout or something like that. See if I can improve my score. So that's it. That is it for this code review. If you like my code review, please like, subscribe, and share. I would like to thank all of my subscribers for supporting my channel. Thank you so much for watching my video. I look forward to making more videos in the future. So thank you again, and I will be communicating with you in the next video.